All right, let's see active testing. So what is active testing? Active testing pretty much is a simulation. It simulates an attacker attempting to hack your APIs. At the end of the day, that's what it does. It is designed primarily for pre-production environments. Okay, pre-production environments. I would personally, and this is my personal opinion, I will never use active testing against production because, as you will see in a few minutes, it is very intrusive. That creates records, it deletes records, it updates records pretty much, right? And it uses some bogus values and so on. So using something like that in production, it could be painful, right? At least from the perspective of cleaning up what you've done already, right? So in my humble opinion, and this is just my opinion, you should never use active testing in a production environment. Always pre-production. Keep that in mind. Okay. Now, if you really know what you're doing and you really want to have active testing in production, well, you can. But I will definitely not do it. All right. The way active testing builds its test and scans for vulnerabilities by understanding all the different operations that are provided by your APIs. Okay. And it's able to do that by understanding what are the dependencies, the relationship between API operations. For example, you have one API that produces, that creates data, and you have another API that consumes that data, that retrieves data or updates the data. All that relationship must be built against your APIs in order to be able to be tested appropriately, right? You do not want to test your APIs in isolation. You want to test them with respect to the relationship with one another. And thank God, active testing has the ability to do all these dependency resolution, dependency understanding between your API operations for the most part automatically. Sometimes it needs help, right? But for the most part, it can get all that done automatically because it has that know-how. And there's a fair amount of AI, guys. There's a fair amount of AI under the hood on this portion. Okay. All right. So how does active testing uh, organizes the data, the information that you need in order to make use of it? Well, it organizes them the same way your developers organize the data. So there is an application, there is a notion of applications, and every single one of those applications has a set of settings. And the settings is where you go and you configure environment. The same way your applications are in a different stage in the life cycle. For example, you have in development version such and such. You have in QA the previous version. You have in production the even earlier version, right? So the same way, active testing needs to be able to reflect the realities of your applications in their corresponding runtime environment. So that's why you may need to define different environments so that you reflect the situation in the different stages of the life of your application. Okay. You need to provide sources or API sources. What are these? This is how active testing understands uh, and discovers API operations. Okay. And again, for a developer, when I say API operations, when I say APIs, it's very clear what I mean, right? But for non-developers or developer lights that have not worked with APIs, this nomenclature that I use may be a little bit confusing. So let me clarify it. From a developer's perspective, an API is a set of operations, a set of related operations. They're there to manage data, they're there to to implement some business process, and so on, right? From the perspective of security, an API is one of these operations. Okay. So when I say API operation, I'm talking about one API, right? One API that you can think of it as in isolation. All right. So API sources pretty much is how active testing discovers APIs, right? So currently RESTful is supported, GraphQL is supported, and these are some of the ways you can actually help active testing discover these APIs. In our case, we're going to be using across the board OpenAPI specification files because it's the most complete way of discovering APIs. I could have used RAML, but RAML is another format that is not as popular as OpenAPI specification, right? So both OpenAPI specification and RAML is one of the better ways to introduce APIs. Why? Because it contains complete descriptions of your APIs, right? Complete. Because within an OpenAPI specification, I'm able to define typing information, something I cannot do with a Postman collection. So if I was in your shoes, I will strive to build OpenAPI specifications, or at the very least RAML. Right? I'm not going to depend upon Postman collections, HAR files, curl collections, and so on to discover APIs, even though I can. Right? Even though I can. The recommended way, the best practice way, is you have something that is complete. A Postman collection is going to contain sample data. It's not going to give me all the typing details. Right? And OpenAPI specification or RAML file is going to give me that extra piece of information, right? The typing details. And of course, every time a user makes use of your APIs, they need to authenticate. And there's gazillions, there's like almost a dozen different ways that active testing supports in order to allow you to authenticate your users, your API users. Basic, header, cookie-based, OAuth 2.0, Postman collection, and so on. In our case, we're going to use basic, we're going to use header, and we're going to use Postman collection. Okay. Now, scans is how you actually trigger the execution of all the tests that will be able to discover security vulnerabilities. And of course, these tests make use of test profiles. And we're going to talk about the test profiles in due course, right? Now, a scan can be triggered manually on a schedule or as part of a CI/CD pipeline. In our case, in this class, we're going to deal with triggering most of the time, and at some point at the very end of the class, we're going to deal with a CI/CD pipeline, right? And of course, you discover security vulnerabilities, security issues, and so on, and those are displayed to you, and their life cycle is also recorded, as we shall see. You can integrate with tools such as Jira, Slack, you can email, and so on, in order to communicate findings out of active testing into other applications. Okay, so that's what active testing is. Now, what's the rationale behind active testing? Right? Why would you want to use active testing? Primarily because you need to enable your developers to think about security. That's the main reason, right? Enable developers to think about security early on. Again, I was a developer most of my career. I will tell you straight off the bat that security wasn't my primary concern, right? And I bet money that a good chunk of you who are developers and listening to this, you're nodding right now, right? Some of you that are better developers than me, right? You probably are not nodding. You probably wave your head side to side, indicating negation, right? So, but I'm telling you, most of the developers, they don't care about security. What they care is to implement the next great feature in the allotted time. Right? Again, we have deadlines we need to follow. Right? So we can't think of everything. That's why we have all kind of different teams thinking about security and all kind of different tools to help us develop. Well, here's another tool, active testing. Okay, that's going to help you think about that. Not only is going to help you think about security, it's going to help you identify those security vulnerabilities and fix them early on during development, which is the sweet spot. It is a sweet spot. It's going to cost you, it's going to take you a lot less time, cost you a lot less money to fix a security vulnerability during development as compared to production, right? And again, you may think, if I'm able to test and fix my application during development, well, what if the quality assurance? Why can't they do that? Well, because they do not understand APIs as well as developers do. And again, APIs, application programming interfaces, are built by developers for developers, right? It's not a product that has a user interface or something that's going to help a quality assurance professional or even a security professional who are not developers, right, to actually understand it and identify it. Yes, a good chunk of us, right, quality assurance professionals, they're ex-developers, like myself, being a technical instructor now, being an ex-developer. But I wouldn't say everybody's that way. So that's the primary rationale behind it, right? That's the primary rationale behind it. And of course, what are the main benefits? I already mentioned a few of those, right? So here's some of them, right? So it prevents attacks. Why? Because you're fixing all your security vulnerabilities or most of your security vulnerabilities during development. And again, I like to say that a security vulnerability is nothing else but software bug, right? At the end of the day, most of these security vulnerabilities are because of a software bug. That's what they are, right? So if they're a software bug, well, let's fix it at the right time. I'm not saying that everything is related to the developers, right, writing code, but for the most part they are, right? Maybe an infrastructure issue. Anyhow, besides the point. Well, if you're able to find the security vulnerability during development, well, guess what? You're able to also fix it a lot faster. And you can easily understand what I'm saying because you already know how long did it take you to fix a bug that was discovered in production as compared to one that is discovered in development, right? It's a slam dunk. You improve compliance. Why? Because you're not going to be subject to whatever regulations that are part of your jurisdiction, right? So that if your security vulnerability is detected in production, well, you're probably liable, right? You lose your customer data, you're definitely liable, right? So keep that in mind. Um, the bottleneck of fixing bugs in production as compared to fixing them in development time is right there, right? So it's going to be eliminated for the most part. You're not going to have anybody communicating, hey, we find a bug, and then you're going to put the bug that you found in production, put it in the next, I don't know, sprint, right? Fix it, then release it, and so on. Or maybe a hot fix, who knows, right? You optimize testing. Why you optimize testing? Because you're doing it, right? The developer is going to go ahead and do all the testing that is required at development time by using active testing, the tool, your assistant. Okay. And again, you boost confidence at the end of the day that, hey, I fixed everything that I need to fix during development, so I don't have to worry what's going to happen in production, right? Well, you still have to worry, but at least it's not going to be something obvious, something immediate. Okay. And with this, my good people, we explained active testing, at least from a presentation perspective, from a theoretical perspective. Okay. What we're going to do next is we're going to go ahead and start the exercises. All right, we're done with the slides. We have 3 exercises back to back to back.